evening, everyone. Welcome to our tonight's meetup. It's hosted by K8SUG Australia, and it's our 14th meetup since last year. Actually, we just marked our 1-year anniversary of last month. So yeah, a big applause for our group expanding so rapidly. Yeah. And my name is Susan, and I will be your MC for the evening today. And just to take you 1 minute to introduce myself. I'm currently, actually, it's my first day of my new role as the technical instructor at NAP. Yeah, very excited and some boarding still. And actually, I also my 1-year anniversary this month with K8SUG volunteer organizing team, K8SUG Australia. Yeah, so this month. So yeah, I grow with K8SUG Australia as well. Yeah, very excited to share. And so next, so first of all, on behalf of K8SUG Australia, I respectfully acknowledge the traditional land of the Kulin Nation people, and we pay our respect to their elders, past, present, emerging. Please allow me to just take a quick preview of what's in covered for today. So we'll begin by welcoming our K8SUG founder, Yongkan or Louisa, give us a brief introduction to our K8SUG group. And following by that, we have an exciting lineup of speakers and topics planned for you. First up, we will hear from Alexandra and Gaurav from Susi, who will be delving into the topic of ration and harvester. Then Olga from Energy will take the stage to share insights on urban LLMs deployment. Then we move to a quiz to challenge you your learning for today's topics. So keep attention. The winner from the top of the leaderboard will have the first pick of our awesome prizes and swags. So we will show you what we have today for the winners. Then finally, we will have our traditional session of a Mac, and also we'll end up our group photo for tonight. Yeah, so I think it's time to hand over to K8SUG group founder Louisa or Yongkan, who would love to come to have an intro for our audience. Thank you, Louisa.
Thank you so much, Susan, for that lovely introduction, and a very warm welcome to you all tonight. Thank you for joining us at our 14th Kubernetes Australia meetup here at AWS Melbourne office tonight. So, as mentioned, we are very proud to progress to our 14th, and many of our original volunteers have been with us for a year now. And we're very grateful for all our existing and new volunteers, and welcome anyone who's also interested. So our mission, since we were established in 2022, is, since we're very passionate about Kubernetes technologies, our mission is to accelerate these technologies and to learn from each other and share the best practices. Once again, very big thank you to all of our volunteers and organizers, many of whom are present tonight. So we had Susan earlier leading this meetup. She has coordinated from the start to just now. And of course, Yongkan and many people, Yen and Jeffrey, Rodriguez, and also Alexandra, and I believe we have Sally at the back joining us. So again, this is Louisa. I'm currently studying computer science and commerce. And tonight we have our main sponsors, which we're very grateful for. So our long-term sponsors, CNCF, Hope Cloud. For tonight's event sponsorship is AWS, of course, who's very evidently. So thank you for the food and drinks and also the upcoming topics. So a quick breakdown of our global footprint. So as you might know, we're not only existing in Australia, but we actually just started in Singapore. So we began our in-person meetups all the way in September 2022, where we were fortunately able to expand here in Australia, Melbourne, and also in Toronto and Canada. So if you see any of our recordings available online, and also the United Kingdom earlier this year. So we hope to continue expanding, and if you can join any of our events virtually or just via recordings, And here's quickly some upcoming events, as you can see all across the world there. So the next one would be in the UK to be confirmed, but many of them we're very happy to collaborate with AWS all over the globe. Just as the very next one here in Melbourne is on the 23rd, again, this venue. And finally, here are some QR codes if you're interested in joining us as a future speaker, volunteer, or sponsor. Thank you again, and I will hand over to Yonkang to talk about the Group Astronaut Program.
Thanks, Lisa. Good evening, everyone. I want to show off, my blue jacket. Have you guys seen this? No? Yes? Yeah? You guys hold over AWS blue jacket? No? Nobody? So AWS actually, if you are fully certified on AWS, that means you complete all the public cloud or more, exams, and you get the AWS blue jacket. We made a suggestion to CNCF or Linux Foundation team. So I'm fully certified on Kubernetes. Why you guys not making a blue jacket? Yeah, they actually made it. They made it. They announced in the keynote in Paris to become event. They announced this program. So I'm kind of like a keystone of the ambassador. I'm helping more people to get trained and get certified on Kubernetes. So that will simplify your cloud journey to help him makes your life easier when you're doing your day-to-day job. I'm also talking to quite a few companies, mainly in the Kubernetes space. So I told the Linux Foundation team that's the host thing. Why you're asking me to pay like $400 for one exam? It's not going to happen. I'm not going to pay. So I asked them to give us some discount. And it's 10% doesn't work. 20% also too low. So we asked them to give us 47% for the cube astronaut. It's a bundle. Okay, if you do all 5 Kubernetes exams, so in total, probably you need to cost like $1,500. That's just way too expensive. So they agreed to support the community. But this code actually supposed to up to 30th April, but it's US time. You give it a try. If it's expired already, let me ask them again. Okay, hopefully we can get some more, extended for this, program. If you do,
you have
Kubernetes is only 5. If you think about the Kubernetes, in total 5 exams.
Yeah.
So I got all 5.
Okay.
Yeah, I'm pretty much globally the first one. Yeah, and I was also, if you notice, there is a Cube-astronaut LinkedIn page. So in 2 weeks, guess how many followers? LinkedIn Cube-astronaut. Anyone want to take a guess? The 2 weeks, 1,000 followers. That's growing very fast. I'm also very surprised. In like 2 weeks, I already seen a lot of people becomes new Cube astronaut. So I'm actually was helping Linux Foundation team. I manage the Cube astronaut LinkedIn page. So that's why I know how many followers. I also do the reposting of who actually becomes a new Cube astronaut. Okay, so with only the exam voucher, you also need to get trained, right? So Code Cloud is the best learning by doing learning platform for Kubernetes. So we also managed to get the best discount. You never see on the public side. You can see if you post a note, if you do the pro version yearly, you can save like a 49%. Okay, I personally don't like to pay. The best option, you ask the company to pay. Ask your company to pay. The company also can save 40% off. Okay, I hope you guys like it. If you guys like the idea, help me to promote, these, and hopefully we can get some more exciting benefits I can share with the community. Okay, this is a KubeStream. So it was announced, as I say, announced in KubeCon in Paris. So we got like 14,000 people on site on the event. And this is exactly the same jacket I was wearing. Okay, I do encourage more people to get certified and to get trained on the Kubernetes. So any questions, feel free to ask me or ask the group chat, ask our LinkedIn page. If you have any questions, feel free to pin me to ask us. So with that, introducing our topics for tonight. So first of all, thanks to SUSE to sponsor us. So we've got very exciting topics. So have you guys heard of the Rancher or Rancher by SUSE, acquired by SUSE some time back, right? And they got a very good offerings. I also tried. I actually also created a few videos about the Rancher, about RKE, etc. And they also will talk about the Harvest. That's one of the also very good offerings. So like on the same infra, you can run VMs and the Kubernetes containers, which is a good thing. So we have Alexandra Settle and Gaurav Mehta. We'll talk about these two topics, and followed by we got Olga from ANZ Bank to do a sharing session about AI open LLM. So the reason I want to shift my Kubernetes user group. So we are still calling K8SUG Kubernetes user group, but we want to stay relevant. If you look at the whole market, everybody is rushing to AI. So actually a few weeks ago, I traveled 5 weeks to join multiple events. Everyone is talking about AI. Microsoft are hugely heavily investing in AI. I was in the KubeCon events. Every vendor is talking about AI. So as a cloud protection or professional IT professional, we have to learn AI. That's why I shifted my Kubernetes user group. Let's stay more relevant. Let's learn AI. So I'm glad we have Olga will join us to do a sharing session. So that's the topics for tonight. So with that, let me hand it over to Alex and Gaurav to talk about a Rancher. Very good offerings. Thanks.
Give me a minute because this is always a good issue.
Well, you guessed it correct. Yeah, GKE is very tough.
I got the alt three, that's why I was just, I wasn't aware of the two, that's got the G.
Yeah.
I got the one that is relevant.
So you did the CKE, and the CKE.
Yes, that's right, it's not the cloud thing.
Yeah,
I was using
oh,
Kubernetes.
yeah.
I just, that's the
Oh,
prelogic.
yeah. So the KC and the KC.
Creature from.
Yeah, these two actually really.
Yeah, sorry.
Yeah, that's right.
It's easy. The three you did, it's completely hands-on, it's more tough. But the two you haven't done, it's multiple question, multiple choice question.
It's multiple choice,
Yes.
not hands-on.
It's not a hands-on. Yeah. So
But that should be
really easy. You can make it like maybe 1 week. You will keep it. Any other questions?
Oh, I can't. Yeah. Sorry, everyone. Technology is really difficult. I think I said last time too. Okay, hi, how are you going? Having a good Wednesday? That's the spirit. Alright, so for those who don't know me, my name is Alex. I was here back in March and I thought this was going to be my only time coming down to Melbourne to talk to you all about what we're doing. But turned out you like my style. So I'm here again with my good friend. But this time we're going to talk about Rancher. So I am a product manager at SUSE. And when I came down in March, I was a product manager for a hyperconverged infrastructure platform called Harvester. Anyone familiar with Harvester or, well, actually first, who was here last time in March and remembers me? Okay, yeah, okay, cool. All right, that's interesting. So who knows Harvester at all? Okay. Who knows Rancher? Okay, a few more, not much. So, one brave soul, tell me What do you do? What do you use Rancher for?
To manage multi-cloud clusters.
Is that what you do?
Yeah.
Okay, so tell me a little bit about that. Tell me about your experience.
So if you want to use all of the clouds,
Thank you. Sorry, I should have asked that.
if you want to use all of the clouds, then having a tool like Rancher so that you can launch your clusters in multiple clouds, spin them up, turn them down, depending on swap prices, for example. And then might be pretty good for that.
Cool. So you're using this in production at the moment?
I've used it in production, so
Okay,
I'm never doing anything now that I was doing 3 months ago.
fair enough. Right, well, it's 1 to 10. You don't need to tell me anything with your experience with Rancher.
I thought it was a 7 or 8. I liked it.
Like that. That's pretty good. Okay. Any other brave soul want to join in? You may have the same questions.
Alex is not the PM if you want anything done.
Okay, so the reason I am asking is because when I came down in March, I was the PM for Harvester, which I still sort of sideline help out with, but I'm just the PM for Rancher. So what we're going to talk about a little bit today is Rancher, and just to give you an idea of where I'm at for this presentation, I have only been PM. So I have a little bit of notes here that I will be referencing. But what if I want to take you through is like a bit of a high level overview, and then Gaurav is going to show everybody a bit what's it all about. So, and then you can ask us any questions. So, as I said, Rancher overview, why Rancher, down. I think one of the most important things that I find when I go to presentations like this is you kind of get an introduction to a product, right? And people say, okay, we've got Harvester, we've got Rancher, and everyone goes, okay, that's great, but why would you even build that? So I kind of want to
Okay.
Okay, so sort of back where we were, right? Pressing and exciting problems to solve. Okay, so 2014 in particular, like I know I was on OpenStack, for example. That's how much the landscape has evolved since then. Not that OpenStack is still very relevant, but not to this enough. So Rancher Labs, they've got a lovely little Silicon Valley startup, and they wanted to create software that would simplify the lives of teams who were building applications using containers. And they wanted a tool to manage all the clusters, right? Which is a fairly straightforward, understandable problem to solve, right? But it wasn't being solved inherently in the market. So, especially with, I think I should mention, especially with like users that are in multiple projects across clusters, which would be really important at the time. So this came in, as my friend just described, multi-cluster orchestration platform that lets operations teams deploy, manage, and secure enterprise Kubernetes, which is definitely on the website. And isn't this? So who's familiar with the cattle versus pet analogy? Just the one guy. 2. Okay, so no one's familiar with cattle versus pet? Okay, so just a little quick overview, because this also sort of explains a little bit of the history of Rancher. So, cattle, right, if you have a pet, you nurture it, you look after it. This is my passion, and I'm gonna make sure cattle inherently need to be spoiled, right? You said like you have your cow. This is obviously a terrible analogy, which is why people stop talking about it. But you have your cow, and you can put the cow in the entire time. So that's what we're talking about. And VMs have you actually server, make sure your server is mindful and nice. So branches, and create branches. And currently, your branch, American style branch, people start from. And when they start spinning out projects, so you have rancher, you have a longhorn is a cow, and then you have cluster, machines, so to harvest everything, right? So there's a big bunch of clouds. And so that's them too, right? They want to create software that things like it, and this is what they come up with first. So it gives you, this is just a sort of trick, look, I don't like too many wordy slides, so they just really want you to do manage Kubernetes. So operate as a management tool, use it and run clusters anywhere on any device. So anyway. So this is how to manage users in one location and apply all the tool projects. It also provides a looking class, so that's kind of why this is here, for looking classes and configurations. So a little earlier, I was having a chat, and one of the things that was mentioned was exactly that, the single pane glass, right? One of the most frustrating things I think most of us have found is, you are working in an environment, you want to send things up, you are using projects, all of the how we one place, oh God, right? So that's the way this is going on. Sorry, switching. So we're going to start with okay. So this is a little bit of a high level architecture view of Rancher. So the fitness regulations Rancher 2.0 onwards, so 1.5 again. And everything runs on what's Rancher server. So Rancher includes all the software. Rancher server includes all the software components used to manage the entire Rancher deployment. And this shows a diagram here. Shows us the Rancher server installation that manages two downstream Kubernetes clusters, one by RP and one by which is our Rancher. I don't know
EKS.
EKS, Kubernetes engine or EKS. So just to mention, this is the first time I've done this talk, so that while I bubble through this a little bit. Yeah, so ranchers have the choice of creating Kubernetes clusters with RKE or cloud Kubernetes services such as GKE. Clusters created using so for the best performance, we do recommend a dedicated Kubernetes cluster for the rancher management server. Running using workloads on this cluster is not necessarily advised. So once you deploy rancher, you can create or import clusters for running your workloads. Rancher can provision Kubernetes from a hosting provider as well. Provisioning 2 nodes and then install Kubernetes on them. So it adds value to Kubernetes by providing centralized authentication, RBAC, the clusters, you can control faster access from one location. Okay. Yep. I should have skipped that earlier. It enables monitoring and alerting for clusters and their resources, ships logs to external providers, integrates directly with Helm by the application catalog. If you have external CI/CD, for example, you can plug it into Rancher, Rancher includes our project fleet, so you can automatically deploy upgrade workloads. So fleet is something that I would recommend. Again, so another day. Your risk, I mentioned when you don't need Rancher. And that would be fairly certain premise. If you only have one cluster, with only a few users, and it's only managed with CLI tools, Rancher may not be the best thing for you, right? It adds more complexity than you probably need. So, yeah, in addition to the one more node branch cluster, lots of infrastructure, DNS entries, backup and others. I'll leave it as I'll let that one sit for okay, cool. So, So for the last 4 years, we continued to develop and build upon those foundations. And basically what we ended up doing, so this one you can't really see quite clearly, we've got several projects. We're not necessarily new, but a lot of them you'll be seeing in the Google space as well as the Archer space. So I can Longhorn, UVEC, and Ordinary Security projects. And so for a very 5-second quick sales pitch, which I always probably hate doing, but anyway. So now we have basically like what's called Rancher Prime, which is our SUSE offering, and that is all for your open and interoperable container management needs. With trusted and secure delivery and complete lifecycle management. That's the same pitch. Yeah, I won't go into that further. I want Gaurav to show you what it's all about. Okay, good. Perfect. Oh yeah. Okay.
Any questions or ask?
Actually, so what happened to the HCD old cluster? Essentially, it is. So what happened to the cluster one?
That's not shown, but each cluster is running its full HCD. It's a fully self-managed Kubernetes cluster. So even if Rancher goes offline, it will keep working.
So that is not.
It will based on the type of cluster type. For example, if you use a self-hosted one like RKE1, RKE2, or K3s, then Rancher will also manage the provisioning upgrade lifecycle of HCD. Because without HCD, there's no state storage for those downstream clusters. Obviously, for EKS, we do not control HCD, but for managing the lifecycle of EKS clusters, Rancher will make API calls to the AWS services to trigger the upgrade cycle, etc. Yeah, but HCD is there. Okay. I think I'm sharing the right screen. It's fine. I need to do something here as well, I think. Make sure I'm sharing the right screen. Hold on. Perfect. This is Firefox. All right, so I'm gonna walk through Rancher. I think I should zoom in a bit more.
Share in the Zoom yet? Can you share in the Zoom?
Okay, sorry. Better?
Yeah.
Thank you.
Got it.
So yeah, so this is what Rancher looks like once you have it set up and logged in. Obviously, Rancher itself ships as a container and also as a Helm chart. So the actual products in the container, all the components it needs to run, and it also there is a packaging for it as a Helm chart. So if you wish to install Rancher, you can just run the Docker container on. If you do not wish to use it for production grade workloads, just do a Docker run, name of the image, expose some ports, and it will pop up. And then you can log in and start creating those clusters. You can obviously also install Rancher on an existing Kubernetes cluster, which is generally the preferred way. And there's logic in the product to identify that it's running on a Kubernetes cluster, and then it uses the HCD of the underlying Kubernetes cluster to store its state for all the objects that it's going to be managing. Once you have a harvester running, it's really easy. You know, we are here to see cluster management. So you can add your cloud credentials. For example, pick one from here, and then, you know, go about creating Kubernetes clusters on these cloud providers. I'm sure there's other cloud providers as well in terms of the drivers which aren't enabled, but you can enable them if you wish to. So I'm going to jump in right to creating a cluster. So right. So to create a cluster quickly on AWS, I'm going to use a self-hosted option to walk you through the process of doing that. I'm just going to choose AWS. So now we specify the details for our cluster. So for example, name. Then we have to provide machine pool. So this is again corresponding more closely towards cluster API, where you need to define the machine pools, the roles for the machine pools. In this particular case, I'm gonna spin up a 3-node cluster with a single pool. Then I can choose a VPC subnet, and yeah, I guess that's about it. So now it's the important stuff, like what Kubernetes version you wish to install. So for the self-managed option, you have Rancher has 3 distros, RKE1, K3S, and RKE2. So you can choose one of these options. So this is the V2 provisioning. So that only shows RKE2 and K3S. So for example, let's choose a version, a CNI that's packaged with RKE2, and any customizations you wish to do, for example, when this cluster is provisioned, can also be done here. For example, configuring private registries to pull the artifacts for bootstrapping the cluster agent components, etc. And subsequently also pulling more container images if you wish to do that. Again, HCD backups, because we are self-managing it, we can also configure how frequently you wish to backup HCD, and also back those snapshots, HCD snapshots, to S3 bucket, and this can be used later on if you wish to restore the state of a cluster. So without further wait, so we'll just submit this cluster creation request, and now Rancher will start making the API calls to provision some EC2 instances, bootstrap those EC2 instances with a custom cloud init, which has information for those instances to install a Rancher agent. That agent, in terms of the provisioning lifecycle, talks back to Rancher, and then Rancher gives out instructions on how to bootstrap all the various components like HCD, and then subsequently the API server and all the other Kubernetes components. Okay, so it's gone. So we can do the same on, if you are hosting yourself a private cloud provider like VMware, or in my case, I have access to Harvester. You can do the same there as well. Same idea, except, the details required for Harvester are slightly different, but again, I'm specifying the image to use, which is OpenSUSE in this case, the network to attach the VMs to, and again, down to the Kubernetes version. So for this one, we'll choose maybe K3S, just as an example, and again, similar customization options for K3S. And we can click create. And now again, Rancher is going to use its own CAPI abstraction along with its own machine drivers to make all the API calls to the correct cloud providers to bootstrap the VMs. And once the VM is provisioned, the subsequent Kubernetes bootstrap process is more or less the same. Their agent is installed, agent dials back home and asks for the next set of instructions, and Rancher gives out the instructions that this is what is needed on this particular node based on the role allocated in the machine pool. So that's provisioning. Once you have a cluster provisioned, you can easily interact with the cluster, manage the resources in that particular cluster. So for example, once you have the cluster, you can manage the workloads, deploy apps, which is a set of curated Helm charts. So you can bring your own app chart, Helm chart repo to Rancher and use that to deploy your workloads. You also have something called as cluster tool, which is like commonly used in curated Rancher app integrations. For example, logging, monitoring, new vector for security, Longhorn for a storage provider, etc. that can be deployed to this cluster. So for example, let's deploy monitoring. I'm just going to go with the defaults, click install. And that will trigger the chart install of this particular chart on this downstream cluster. So right now, the monitoring chart is basically a wraparound of Prometheus with some customization. So it's installing the CRD chart, and then it will subsequently install the actual Prometheus chart. And it should be done shortly, but I'm not going to wait for that. So in terms of lifecycle management, you've seen how to provision a cluster quickly, how to access and manage the workloads on the cluster. Using Rancher, you can also manage the life cycle of the cluster. So for example, perform Kubernetes version upgrades. So when a new version of Kubernetes is available, by default, Rancher has a upgrade responder service that it polls if you are not in an air-gapped environment. And it will poll that endpoint every 24 hours to see if new versions are available. If it's available, it will download that information. And once that information is available, you can perform Kubernetes version upgrades. So for example, you can go up a version, click save. And this will trigger an in-place upgrade of your Kubernetes cluster. So again, that agent that dialed in the first time to bootstrap Kubernetes, it's there, and now it's listening for instructions on how to upgrade the various Kubernetes components. So I guess within 10 minutes, this should be upgraded to the newer version of Kubernetes. So apart from this, the other key reason people use Rancher is for authentication or for fine-grained RBAC. So the other Rancher I have is already federated with an identity provider. So I cannot change much, but this is a freshly installed Rancher. So once you have installed Rancher, generally end users tend to set up an auth provider. So you can use one of these identity providers, for example, to choose for authentication. And once you've set up an identity provider, then users can use that username, pass credentials from that identity provider to log into Rancher. So for example, hold on. I think I zoomed in and so I can log out. So for example, in this particular case, I am using just a local identity provider. So, but once you have set up a non-default identity provider, say AD or LDAP, you would use your AD or LDAP credentials to access Rancher. I was pretty sure I had the securest password. So yeah, so once you have your identity provider set up, now you can use that identity provider to do fine-grained RBAC. So for that, we have something called as projects, and the projects is basically a grouping of namespaces on which authentication or fine-grained RBAC rules can be applied. So While I do this, I can answer questions on the chat. Okay. So here we go. So projects and namespaces. So basically, by default, there will be 2 projects created on every cluster, the default and the system. If you can now create another project, for example, demo, and now you can add users from your identity provider. So for example, I know a few GitHub usernames that. So for example, you can provide use a username, select a user from your identity provider, provide them specific access to the resources in the project. And once this particular user logs in, they'll only be able to access the resources with the RBAC that you have provided them to the said resources. So this is as simple as that. And, that's how we manage RBAC across Rancher. Yeah, I know. That's the only idea I remembered. And what else? We also have Fleet, which is for our spin on GitOps. So I can show it here. So Fleet is basically GitOps for multi-cluster world. So things like Argo or Flux, you need to deploy, and configure individual clusters for use with GitOps. With Rancher, one of the things we do when we manage the downstream cluster is we automatically deploy a management agent for Fleet on each downstream cluster. And the idea is you can group your clusters into groups. So for example, you can create a cluster group using labels. So when you provision the clusters, you can add labels on the cluster objects because that's also in the CRD. And you can assign use those labels to group clusters, and that cluster group can now be assigned a Git repo, and all the resources from that Git repo get deployed to that particular cluster group. And there's various functionality in terms of rolling out how many clusters get bunched as part of the rollout, and so on and so forth. So yeah, that was my quick and easy demo for Rancher. As you can see, this demo cluster has been upgraded to 1.27, and I've managed to not break anything. Any questions?
Yeah, good question.
Sure.
Yeah, 3 questions.
Yeah.
Number 1, how much do we create this cluster using infrastructure scale? Let's say what is Terraform? Do you
Yeah.
have like Terraform?
Yeah, we have a Terraform provider. So whatever I did in the UI, you can do through the Terraform provider.
Right.
And using a combination of, as we've seen customers do, a combination of Terraform as well as GitOps.
Right, so I can just create the cluster using Terraform.
Yeah.
Cluster, but then it's the number of clusters.
Yeah.
And then 2, so your dashboard on console.
Yep.
This is only a SaaS platform. Can I install it in-house?
You can install it anywhere. I just happen to use a SaaS platform that our support team runs, so I don't need to install it for this demo, I guess.
Yeah,
But
that's fine.
yep.
I just wanted. And number 2, so you use SaaS, so you connect to the clusters.
Sorry.
Your SaaS product.
Yep.
You connect to the cluster.
Yep.
To stretch your data, let's say.
Yep.
So the RBAC to allow that whatever the your SaaS platform to collect that data. So the RBACs of the Kubernetes RBACs.
Yep.
They are created as part of that contract, or at what point you created?
So the RBAC is created by a controller that runs within our Rancher. So basically,
Is that the delta that you just mentioned?
No. So Rancher itself is a bunch of Kubernetes controllers. All of Rancher is hundreds of Kubernetes controllers working together to get you to the desired state. One of the controllers is to set up RBAC. And what it does is So the first thing it does is provision the infrastructure, do a cloud init. That cloud init says, hey, as part, bootstrap this VM and run this agent, and to download the agent, come back to me and I will tell you how to download the agent. And it's simply a curl script to download and run an agent. That agent talks back to Rancher. And
As a kind of even set of something running inside the cluster.
yeah, so the first agent is just a system D service. If we haven't gotten to Kubernetes yet, that agent will now get the instructions to bootstrap a Rancher. Once, Kubernetes, like RKE2, K3S, RKE1. Once that Kubernetes is bootstrapped, the next instruction, it'll tell Rancher the bootstrap is complete, because it's got, checks in there to check, is the cluster ready? Is the API server ready? Is HCD ready? Is CNI ready? Once it tells Rancher that yes, everything's ready, then Rancher sends the next instruction, install this agent and use this RBAC. And that cluster agent now talks back home and say, I'm ready now to, and whatever happens in the UI now, like managing and browsing the workloads, is happening through the proxy that that agent has set up to talk back home. Yeah. So hopefully that answers.
Yeah, that's fine.
Yeah.
So, you haven't done any answers for local DC.
Yep.
So to run like this, you have, automatic, Kubernetes cluster, how answers you have on my DC, let's say I'm running my cloud, Kubernetes cluster. So
Yep.
is it like, just like a .exe and installing a DC or laptop if you want, or do I have to create a cluster on top of that cluster and enter the
So installing Rancher is pretty straightforward. I have this helper script. This is basically a shell script. All it does is downloads K3S. And if you read the K3S documentation, it's all documented. You just need to know where to drop the manifest. And once K3S boots up, I drop in a manifest to say, install Rancher. And the only thing, if you want to use it, you can use the script in your environment. All you need to do is change the host name, because that is the host name it will register. It needs to be a valid DNS record. So, and this should be reachable from all your downstream clusters. So all the clusters that Rancher is managing should be able to talk back to this DNS endpoint.
Okay.
That's all we need.
So this cluster which we have installed on that, so we have to manage that manually, or Rancher will manage its own cluster?
Rancher won't manage the local cluster itself. So you will have to manage the lifecycle of that.
Manually.
Yep.
Okay, one more question.
Yeah, but you can install it on EKS if you are so worried about managing it, or just use K3S. It's not that hard to bootstrap and upgrade K3S in place either. That's why I used an example with K3S, because it's a single binary, and if you swap it out, and it performs the upgrade.
We generally use notice on DC from policy.
Yeah. So I'm running so this Rancher is the second Rancher I showed you. This is running on Harvester in our data center on a bare metal node that I installed today morning. So yeah.
Thank you.
So you've shown us about using the version of Kubernetes.
Yep.
The highest version you had there was 128.
Yep.
130 is obviously been released very
Yep.
recently. How long until 129 is going to be available in Rancher?
She can tell that. No, generally it's like August. Yeah. So generally it's like a couple of months after the actual release is available. So
It's already in a couple of months before it's
yeah. So I'm pretty sure I've seen.
Guest. Oh,
Okay. Yeah. So
Yeah.
So the actual 1.29 is available. I think Rancher will get it probably in the next release. Don't hold me to it. Generally, it's async as well. Like I said, there's an update endpoint. Once that upgrade service is updated with the metadata, it generally pops up in Rancher. No more questions? Yes.
Easy.
Okay, perfect.
Thank you. Thank you, Alex and Gaurav. Yeah, sharing is also the topics, and I can see also very active engagement. So that's nice. And next, let's move to the next topic and welcome Olga from NZ and up to on the stage and hand over to you. Thank you.
Okay, so that all works. Okay, so this is the hardest part is behind us. Which one should I be using?
Yeah, this okay. Yeah, this one.
Okay, so you can hear me all right? Okay, my name is Olga. I'm platform engineer in the NZ Plus, as it is known outside. This is the new digital bank. I'm working with Kubernetes for the past about 6 years. It's bread and butter of my career. I really love Kubernetes and really been digging into this. And I live and breathe Kubernetes. I really love it. And as it was mentioned in the beginning of this meetup, unless you live under the rock and you know that AI is eating the world, it's happening. And I think we all should be on the lookout. We at least need to know the terms and how that works. And obviously, this is a Kubernetes meetup. I will try to stay as much as possible on the Kubernetes side, but we also need to look a bit into the AI, how that looks like, how it looks like on Kubernetes. So this will be the topic of my talk today. So in terms of what to expect from this talk, there's first I'll talk a bit about the model, how it looks like, what I'm going to be using for the demo. Then after you have the model, so what you actually do with this. So we'll talk about the inference and serving, what it is, what it means. We'll talk about the requirements of what the deployment needs to run the model and to serve the requests, and how Kubernetes cluster meets these requests and demands of the workloads, because we know it's all compute intensive. It has it requires GPU, which maybe that has some additional tricks to it. Then there will be a short demo, and if time left, there's a Q&A in the end of the session. Okay, so LLM, large language models. Today I'm not going to speak too much about the AI side of this, but I'll be focusing on the text generation models. So the models general, like if you break them down into the high level steps, there is a part where you train the model and then the part when you use the model. So I'm not going to talk anything about the training. We will take the model which is ready and deploy it to Kubernetes. Okay, so the model that I'm going to use for this demo is a small Gemma model. It's really small. It has only 2 billion parameters. If you don't know what's that like, the modern ChatGPT-4 or other like high-grade models, they can get to 200 billion parameters or even half a trillion parameters. It's not the only measure of how performant or how precise the model is, but it's one of the important measures. And this one comes in couple sizes. It comes in 7 billion and 2 billion, and each one of them is either base model or instruct, which means the base model you shouldn't be use it as is. You take it to your enterprise or to your data center, and you train it for your specific needs. But Instruct's model is already sort of pre-trained to work with in Instruct mode, where human basically usually gets some prompts and gets their output out of this model. So that's a basic thing that is ready to use. It won't be really precise to your needs, but it's good enough for try and play with this. Okay, this is the Hugging Face interface. Hugging Face is the kind of like a GitHub repository for the open source models and data sets and everything that is involves AI. They have a blog post and community. And here, this model, for example, this is all what model actually is. This is when you say, I want to get a model or download model, you get these files. There is a bunch of metadata here, and the all magic what happens here is in these safe tensors files. This is just serialized weights of the model itself. This one will be about 5 gigabytes of data in it. And later in the demo, we may look into how it really looks like. Okay, so now that we've got the model, what's next? So the model is basically these not two files, but there's a series of weights that are serialized and chunked into these safe files. Now what? Now you need another layer that knows how to talk to this model, how to translate the input from the user to the format that model understands. And then on the way back, you do the opposite. So this is in broad terms, it can be called inference. And then there is also a serving side of it that you obviously have to service some requests over the networks that come from your end user from other application up in the stack. So this is a inference and serving. And then like everything else in Kubernetes, so we'll put this in the pod, and these pods, like anything else, they will need a lot of love. They will need all of these things that we were doing for years on platform. So there is you need to expose it somehow to outside world or to your internal users, and load balancing and resilience and resource management and performance, security, login, monitoring, and all these things. So we've been doing all of these for years for regular deployments, and some of these tools are still relevant for AI deployments, but a lot of them will be specific for the needs of AI, especially the ones around the resource management, because the AI applications are very compute intensive. They require GPU. GPU is expensive, and you want to make a good use of it. The models themselves, as you've seen, just 2 billion, which is tiny, is 5 gigabytes of data. Imagine when we're talking about the much bigger models. So even downloading this data will take a lot of bandwidth time. So you will have to optimize for this as well. Okay, so what I'm going to show right now is basically the bare minimum deployment that's required to run an open source LLM model inside Kubernetes cluster. And just like a basic tutorial or something that if you go through the ClickOps, for example, from Hugging Face, you go to deploy to cluster, deploy to Kubernetes, they will give you this deployment that we'll walk through now. But again, this is the bare minimum, and that doesn't mean that this is how you do the things in real life. So what I'll show you on that first side, which side is this for you? Is left. So on the left, I got this right. So on the left, you'll see this bare minimum deployment, and sometime on the right side, I'll show some better options. They're still not the perfect options, but they're a little bit better. Okay, so the first thing that we see there is obviously an image. An image, it's important to say, image typically doesn't include the data, the model data in it. It is still a huge image. It contains the runtime that is required for the inferencing. And by the way, what is the I'll remove this mouse from here. Okay, VLLM, something that I didn't mention before. So VLLM, it stands for Versatile LLM, and this is inference service that is, it's quite popular, it's very performant, and it's doing this inference part and optimization is taking the input from the user, translating it to the language that model understands. It also has a lot of room for improvements like paginating the attention and many other improvements that are related to the AI serving of the model. Okay, so in terms of requests, it's so we're all familiar with CPU and memory, and here in addition, usually they may require ephemeral storage for temporary storage of the model data, and they will also request a GPU for the inference in itself, for the work that model is doing, all this magic of getting you the answers for your questions. Now, the next thing, from the quick start, you will have this Hugging Face hub tokens. This is the access for the Kubernetes pod to go and actually download the data from the Hugging Face. This is where the model is stored. And the better way to do it is to store it somewhere on your side in your ecosystem. It can be stored as a OCI with the layers, and you can train the model. You can have multiple layers on top of your base model, and in this way, it's more. You can optimize how you download the model in more effective way. You can create init containers that pull the data from your storage, and what else I wanted to tell here? Yeah, so when you store it on your side in your cloud provider of your choice, it is also better integrated with the rest of the ecosystem, and in particular security, audio logging, IAM, and all these integrations that you're used to with your other types of workloads. But even better, you can create a PVC and download this data even before your model starts, even before any pod starts. You can create a special deployment that all that it does, it goes to this volume, downloads the data, and then the model data is already there. So when you go and you deploy your model, it already has the data inside the cluster. So you don't have to wait for all these gigabytes to be downloaded, especially if you scale up and down, it's already there. Okay, and the last thing is very important, is that for inferencing, we really do want accelerated computing. So we mark the selector to select the nodes that have GPU available. Okay, so this is in terms of the deployment. This is how the Kubernetes deployment look like. Now let's look into the cluster. There is nothing special that you need to prepare for your cluster. Basically, all that it needs an EC2 instance or VM or whatever it is that is capable of running a GPU. Now, there is a couple of ways how GPU is provided to you in cloud providers or in data centers. You can have VMs that have GPU already integrated in them. So when you go to machines like P series or G series on AWS, you will already have GPU and CPU on that VM, but you can also have general purpose VM as long as it has compatible GPU driver. You can also do that. And this is what I have in my demo, because I'm I'm more familiar with the Google Cloud. This is what I'm working in ANZ, where Google shop. And my demo today, it will be on Google Cloud, and they just didn't have in Australia, they don't have an accelerated GPU or integrated GPU. So this is what we will see. We'll see the node that was general purpose node, and then with the driver, it attaches the GPU to it and makes it available to the pod. So they don't really know where it is integrated on the board or if it comes through the drivers. Okay, so then, and this is the demo. So let's, I'll try and do it again. This is the heartbeat, is to get everything, all the screens working. So what do we have here? So we have here a cluster that that runs this deployment as I showed you before, with only improvement here is that it's not getting the model from the Hugging Face. Instead, it is the model is saved in the bucket, and it gets the model from the init container using the workload identities and accessing this bucket through init container. And it is here running. Now I need more hands. Well, hopefully you can hear me like this. I'm sorry.
This one.
That's a service. Okay, the problem is that I see it only there. Anyways, we'll figure this out somehow. Okay, what I wanted to show here quickly is we have this diamond set running in the cube system space. This is the plugin, the GPU device plugin diamond set. This is the one that makes this magic that this GPU is actually visible in the node, and this deployment can run. So now if we want to look into this logs of this pod, either model init or init model. Ah, yes, sorry, that's a good point, because I always forget about this. Let's also print this. Ah, I can't do this. Okay. We'll actually look into the logs of this. Okay, I don't know, it's too so tight. Right. Every presentation comes with its own challenges. Okay, let's look into these logs of what did I do? So I want to also bring this up so that you probably can see it better. Oh. It's kind of difficult. So I need containers, so I need model. As you can see, here's it downloading it from the bucket into the temporary volume inside this pod. Init, what's it model init model. Actually, not much to see it in like all these files that we saw on Hugging Face. Here they are downloaded to this temporary location in the pod, and then in the main pod, it's using these fetched files from this local file, and it loads them in memory. I think the one thing that I didn't mention is yeah, this model actually is not stored on any disk. It doesn't stay here. The model data itself will go into RAM, into the memory. And this can be seen in, where's my tabs? So if we go to the workloads, you will see the workloads, and we will look into metrics of this deployment. It has only one pod running, and it's been running for a little while now. You can see the RAM memory of this model. It grows at the startup. So that's the 5 GB of the model data that went straight into RAM. You can also see the GPU usage there. And it's actually double the size. And I think that this is has to do with the precision of the model. I had to actually downgrade the precision because I didn't get the VM too big of a VM. So that's about it. And just for the curiosity of it, I actually also wanted to show you. There's so many things that are in the way. Like this. So, this is the model. So this model can be deployed to any cloud provider. You can see here there is a bunch of options for you: AWS, Azure, and the other options. And just to give you a bit of a example or sneak peek what's inside. So this is the weights, the parameters, what they talk about. This is actually the model, and the B float 16 is the size of this parameter and precision of the model. So there is like 5 GB of this. Okay, so this is about the AI, and we don't go too deep into AI as I promised. And another thing what I wanted to show in this demo, let me remember what I wanted to show. I actually wanted to show how that it works. If it doesn't work, then there is no point into anything. Okay, so here's, I probably already did this. There's a simple script that all that it does, it just sends this curl request to this service. Service is the Kubernetes service that we have only one, this inference VLLM port behind it. Okay, so I'm going to send this prompt, and hopefully there will be answer coming from it. And because it is LLM, every time you ask the same question, you can get different answers. So just to show that there is something else. But the interesting thing is it's a tiny model. So you'll see I had this example for the 30% of world's knowledge. I've seen this already many times during the preparation for this demo. Okay, so this is how it works. And maybe just one last thing is that get nodes. I have only one node here, and again, this is the server image for this container. I'm looking just into the node because here I can easily find the size, and just to give you the example of what's involved here. So this is bytes, this is kilobytes, this is megabytes, and this is gigabytes. It's quite heavy, and this is without the data, the model data. That means that you really, in production, you really should be thinking about all these gigabytes, because downloading, scaling, there is a lot of bandwidth, there is a lot of latency in there. And for data itself, there is a few protocols that allow you to peer share, to share it between the peers, or to speed up the startup of the data of the model pods. Okay, I think that's about it that I had for the demo, and to keep it also short. And okay, let's go back to this. So this is the example that I showed you before. And just a little bit beyond the basics, right? Obviously, you won't deploy single pod like this with simple service. You will need a lot more. One of the things with AI applications that they are very heavy, they require a lot of computational power. GPUs are very expensive, and GPUs themselves, they provide they provide options how to optimize this. NVIDIA has the option to share the GPU among different for, I think, up to 7 processors on the same GPU. Like for CPU, while we were taking this for granted, we say this container needs 100 millicores, and you never even think about this. But if you put just a half GPU, what you'll get 1, unless you configure and you use appropriate GPU that supports this. Another option is the time sharing of GPUs, but you also need a lot more functionality to run AI efficiently. And again, also what I've mentioned before, all of these platform concerns about the reliability, scalability, and observability, and all these things. And K8SUG is one of the frameworks that specifically targeted for AI deployments. It has a lot of cool features for AI and also for the kind of Kubernetes. Here's the one thing is the model mesh, which allows you to run multiple models inside the same pod. And this is obviously makes it more, this helps with the resource utilization of the cluster. And yeah, and I think it's just very cool that you can mix and match in the same pod, you can run different models. And there is also way more to the Kubernetes, AI on Kubernetes than just a pod that runs the inference model. You have the inference pod, you have transformer, you have explainer. You actually, for one model, you end up with the 3 or 4 pods of serving this flow of the request, of translating it from human language to the model language, and then additional, maybe you do retrieval augmented generation, so you look up on the side. The real architecture is way complex than what I showed just before. And this is where K8SUG comes in. There's options that you can run multiple models for the same thing, and you can get responses from multiple models, and then you can combine them together so that to make them more trustworthy, or to compare the models, which one serves your needs better. So this is also provided by K8SUG. Now, what I've showed you so far is, let me do the slideshow. So what I showed so far is all run, the demo, what I prepared was run on my personal account, and I don't endorse or recommend, but this is my way of learning, and I just wanted to show that what involves in it. Basically, when you do it on your personal account with the when you do it for enterprise, it's also very important, but when you do it personally, it's even more important, the security and the cost. And on terms of the cost, there's quotas that will help you to avoid overscaling. There's billing budget that will keep you honest and will get you the indication where you are. It's just the billing information comes late. It comes with delay. Usually it comes next day, so you don't know how much you spent, so don't rely on this. Spot provisioning, always use spot nodes for your tinkering, and do the homework before launching anything. You have to know how much it may cost you. So this is what I usually do. Usually since the since the ChatGPT came to our lives. So I say, like, this is what I want to build. Give me the estimation of how much it will cost, and it will go through all all the elements that are involved in this infrastructure, giving me estimate for this, estimate for that, and then I'll cross-check with the documentation. And for this example, running this tiny model, an hour and a half tiny model on like Tesla 4 GPU, which is not very fancy one, attached to a spot instance node. Like it's not very expensive, as you can see from this. And it's also interesting, gives you kind of the ratio of how much GPU actually compared to VM, which is in this case is a 1-to-1, but again, this is not reflexive of what you'll run in production. Some nodes can cost like $100 an hour, and there is more advanced like 800, 800s. All these latest GPUs obviously will be way more expensive. Okay, so now what's next? There is a lot of resources. There is no a shortage of resources of what you can learn and where you can learn. So what I like, what I love to learn in terms of AI, there is a TLDR newsletter which has several domains. It has DevOps, it has AI security. So with AI, you can just go and it gives you the digest of the latest news of everything that is happening important or interesting. And digest it, summarize it in a few sentences. You can just read it. If you don't understand it, throw it into ChatGPT or whatever model you might be using on product. Explain this to me. And this is how I started when all of this boom started to explode, and I got lost in all these words and all these terms. It was really difficult to follow, but just use AI. It's great, not just for this, but for any learning. Explain this to me, help me understand this. You can also do local development. So this is just one example that you can run it in Docker on your laptop. And it also explains a little bit more in terms of AI. It shows the RAG, which is retrieval augmented generation, which means you have the model, but you also have the local database of your specific content. It may be in your organization, could be data that is internal to you. So instead of training the model that has this data, you actually get the response from model, but you also enrich it with the data that sits in this vector database on the side. And there is a nice diagram that shows how that works in the high level. And obviously every cloud provider has a lot of AI related offering, and each one they will have this kind of hub page which has links to tutorials and hands-on labs and products and whatnot. So in AWS there is machine learning /learn, and if you work with other cloud provider, you obviously can find in Google and find this hub as well. And it's a great way to also get hands-on experience with these technologies. And I think this is all that I had. And if you have questions, we have a bit of time, maybe, I don't know.
So yeah, let's see if we have questions or not. What about in the Zoom? Thank you. Maybe just one up to two questions when we move up. Thank you.
Hi, Olga. Thanks for the talk. At the start of the talk, you mentioned
Yes.
the performance and how, that's one measure is how many what the term now? But
parameters.
what are the other parameters?
Parameters.
What are the other ways of measuring the performance of a model? And then on top of that, to follow up, how do you measure the efficiency? Because I know some models want you smaller, but then they might cover a larger area.
Yeah, they're also built for different purposes. For example, the small models, apart from this, from the fact that it is much cheaper to train them, actually, I think their main idea behind them is that they can run on devices, they can run on mobile phones, they're small enough. And in this sense, the performance becomes relative term, right? You can't run very large model on your phone, but you can run this small model, and then it saves you this round trip to the internet, to the data service and back. But in terms of model, there is also inference plays an important role. What do you want from the model in the end of the day? You want, if we're talking about the text generation, you want the data to cover certain area. For applications like ChatGPT, they want to cover any area because they cater for anything. So for them, this is important that this model is actually really huge. If you want something that is specific to some department within your organization, then smaller model is actually more performant than 500 billion Gemini model, for example. And the next thing, so there is a domain, and then there is also the precision. How accurate is the answers that you get? How can you trust this model? We all know that, especially in the beginning, there were a lot of hallucinations. And if you don't know the domain that you're asking about, it hallucinates so confidently that you can't tell that it doesn't know what it's talking about, right? So that's another area that it's really hard to measure. And this is where prompt engineering tries to find answers to how good your prompts and how good your answers from the model.
I've got a question here. Thanks for the talk. Just want to know, like in general, how do you actually ensure, I'm not sure if you mentioned about it, but how do you ensure scalability of the LLMs deployed on Kubernetes? And do you do it, or is it just like standard deployments kind of? Yeah.
Okay, so for this, I can only give you a theoretical answer because it's just the beginning, and we are not running with these huge models and huge deployments. So one of the approaches is the case server model mesh, for example, is where you mesh you place the models in the same pods, which allow you to share the resources more efficiently. You can pre-download the model data, and you can share. There is peer-to-peer protocols that you can deploy inside your Kubernetes, and instead of going for the model data somewhere to the storage or to the registry, you can ask your peers, like the nodes around you, if they have this model or layers, they will share it and significantly speed up the startup of the model. And yeah, there is obviously a lot more to it. There's models that can't fit into one GPU, and there is solutions to that too. Yeah, I'm not sure if that answers the question. Yeah. Yeah.
Sorry about that. Yeah, because limited time, so we have to stop here. But just feel free and to reach out for hotline afterwards. Thank you very much. Thank you, Olga, for sharing. All right, so hope everyone paid your attention to the two topics. Yeah, are you ready for the quiz, everyone? All ready? I'll give back you 2 more minutes. Let me share my screen on the as well. Okay. Before that, we'd like to input your feedback for us. Yeah, it's quite important to us. Yeah, any pieces, comments, or your feedback, it will help us to improve. Also, we put our efforts to get more bundles for us, like Yongka mentioned. So just here we go. Yep. Does anybody capture the Good. Thank you. Yeah.
Yeah, like Susan said, we really need your feedback. It will help us better, to help our community. And I'm actually, I want to talk about one. This is also, is that like a goal? I want to have. Okay. So we were very happy. We got the 6 tiers. Because the whole of the AMS is 6 tiers, right? So the company used to call 5 tiers. In fact, so that time we AMS only had 5 tiers. And then they introduced another one, so the company also changed it to 6 tiers. So what I'm trying to highlight here is they actually provide us the opportunity for us, our community, to be able to get a free room. It's a best thing for our community. It's also the best thing for the company if you guys are using AWS. If you guys are using AWS, you guys probably call there is a program called AWS Well Architected Program. The company can help your company do an assessment. Once you done the assessment, but based on your company spending on AWS. So the best case is that the company spend like $850 every month. If you spend $850, you can get, the company can apply to get a 5,000 US from AWS. That credit is provided by AWS. And then this company can get your food, okay? But how the company make money? When your company using AWS gets 5,000 US credits, they charge you guys 20,000. I feel it's better for everyone. Right? You can help your company to save money. You can get the food. I don't know. Okay, that's why I don't charge you. Okay, I just if I ask me to help them, I say, why not? Okay, it's better for I think the company only spend like $100 on that. Don't answer yes. Okay. It's only going to happen. Yeah, it doesn't help your company. So when you spend more than $850, you can get it's okay. So we did the feedback. We got quite a few prize. So you guys already seen here. Thanks to Susan. It was fantastic. I also have 2 books. So someone sent me to it. I actually don't have time to read. I just say, read here to share with everyone. Not everyone, only 2. Okay. So you guys take a price, into link in course, you're helping me promote also get it. Okay. So these 2 books, one is an architect, the AWS was Terraform. So if I change the name to IBM Terraform, 2 books. And the other one is in data type of practices. Okay, that's the price for sign, and also I forgot to mention we also have us the free for 6 months. Also, if you are paying, even after all you understand, you still okay. So that's one.
You can, yeah. So you can keep it in stage. Yeah, so me. All right. So and this, and we're going to open testing. Hello. Yeah. Yeah, we have someone pick the small one. Yeah, instead of the and share. Yeah. 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 Sure. Okay. Yeah. Good job. Okay. Everyone. get code, join the board. Can we start now? Right, looks like most of you get into the board. So I will start the quiz now. Start the quiz. Okay, so my project, I think we need to rescan again. I haven't refreshed the leaderboard yet, participants. So we should have the list of the participants here. Sorry about that. Let's scan again. They do have twice, like, yeah, but not sure. Yeah, cool. It's working now. Yeah, so we do have 2025. The numbers going up. Do we have more? Yeah, cool. Haven't started. So waiting, all of you joining. Yeah. Okay, I think yeah, so it's the real start now. First question, are you ready? Each question will have 30 seconds and to allow your answer. The first one, when was Rancho led Summit and then was it acquired by Susan? Hope everyone paid your attention. Easy, isn't it? No. Oh, looks like that. All right, we still have 8 more questions. Do you have chance? Keep up. What does Rancho add on top of standard Kubernetes in store? That's 4 choices. Yeah. Easy. Yeah. Action quickly. Cool. Now we get it. Next. What manager cloud Kubernetes service can Rancho use? Choose from user. Sorry. Rancho use choose from. There are 3 options. All of those 3 questions are easy, guys. Cool. That's it. Yeah, cool. All right. So I just see we move to the challenge now. So keep your attention. Which of the following is not a inference technology? Ten more seconds. Oh, yes, challenge here. Got it? No. Oh, I think we can quickly check the leaderboard for now. Ricky is leading the board at this moment, but probably will change. Let's see. Yep. I'm not gonna read this, so just feel free. Is it challenging? Let's see. Andrew, well, yeah, clipboard changed. Next. I do believe the accurate, the correct is the most important, so take your time. But we still have, yeah, someone paid a good attention. Next. What is the most accurate statement about CPU and GPU roles in inference and serving? Nice, guys. Keep that. Okay, so last second one. What about this time? Not bad. Okay, so Andrew is leading the board, but we'll have one more question. So last question. Let's see, will leaderboard will change or not? Here we go. End of this quiz. I think we end quiz. We can have a full view of leaderboard. Andrew leading the board. Congratulations, Andrew. Is Andrew here? Oh, yeah, got it. Andrew, is Andrew? Yeah. Hello, would you mind come to the stage? And we have a few. Yeah, you have the biggest right to choose whether you like to take. Oh, which book? Yeah, everyone take a photo to capture the joyful moment. Congrats, Andrew. Good. Top one. The next. Jesse? Oh, just give you. Definitely. Or you contribute your prize to us. Evan? Hi, congrats. And come to the stage. Which would you like to take home today? Oh, we like books. Good guy. Good. So next, I don't know what's the name. So it's the guy here. Okay. Congrats. So yeah, just so we have volunteer will reach to you, so you need to leave your contact details for us. Yeah, thank you. And next, we still have more. Yeah, don't worry. Yeah, are you here today on the stage? Welcome to the stage. Nimesh. Congratulations. What's your choice? Make choice. Oh, that's my personal favorite. Thank you. I'll move on. Ricky. Is Ricky here? Congratulations. Cloud access. Okay, the second one. So we have still one more. Yeah. Congrats. Come on the stage. Yeah. It's our helper. But I promise that he didn't know the answer. Yeah, he didn't know. And Ming is Ming here. Oh, congrats. Like says, what take? Oh, the one. Yeah, he wants. Finish. So, thank you, Susan. NKT. Who's NKT? Number 9. NKT. Congratulations. We have a small adorable Susie. Susie. Thank you. Hold on. I'll be sorry for nothing. Congrats. And to number 11. Thank you. Come to the stage and congratulations. 1, 2, 3, 4, 5. We have 5 more. The flash. 12. Congrats. Oh. Thank you. 13. Thank you. Work. Congrats. There's 3 more. What is Austin? Austin here? Austin or so in the Zoom? Let me double check. But we can't deliver. I don't think we deliver. If we can't, so we have to skip the. Where's my Zoom? Lost. Okay, so no. Okay, yeah, okay. Yeah, no, so we're skipping. Vincent, do we have Vincent here? Nice. Congrats. Okay, 2 more. 16. The 4Y, 3Y, yeah. Congratulations. And 17, the last lucky guy. Congrats. Yeah. Thank you very much, everyone. Yeah, hope you enjoyed the tonight. But before you go, sorry about that. So just take 1 minute to take a group photo. Yeah, for wrap up what tonight. Okay, we have some surprise. Yeah, sure.
Yeah, this month of May, we are completely yeah, we have quite a few events happening. This is the first of the month, but we will still have more 2 events this month, only in Australia.
You don't have anything?
You don't know?
No, no idea.
Open the available. If you are interested, it will be.
Thank you. Yes, cannot stop. Yeah, it's working. Nice. Thank you for sharing that. And everyone, so I would like to invite you up to the stage so we can line 2 or 3 rows here. And yeah, back to the screen and the face the seat. We'll take a group photo to wrap up of today. Thank you. Come on, don't be shy.